Hey everyone, so now we're going to do the help video on predicting products. This I hope will be very beneficial to you guys in helping you do the assignment which will follow this, okay? Please, please, if you have any questions, this is probably the most difficult assignment of this entire chapter. So please ask questions if you have them. What you're going to have to do is I'm only going to give you a portion, a portion like either the left side or the right side in a word equation of the predicting products. So the idea behind this is you're going to get the word equation, you have to finish the word equation, then build the formula equation, and then balance it. So this is like a three-step process. This will be the hardest thing you're doing, and you will have to do it on the exam. So it's very important that you guys practice this so that you know how to do it for the exam, okay? All right, so I'm going to share my screen. All right. There we go. I'm going to move this down a little bit so that we have everything in there. All right. So this is how you're going to be doing it. So this is what your sheet is going to look like, but you're going to have more problems than just 5. I'm actually giving you an example of each type of reaction you will potentially see. Okay. So I'm going to go ahead and move this up here. All right. So the first thing is I'm going to look here and I have lithium phosphate. So an element and a polyatomic, that's going to be a compound plus another compound. So if I go to my foldable and I look at my foldable, I would see anything with a compound plus a compound. There's only one type of reaction that could be, and it's actually a double replacement. Okay, so now I know what kind of reaction it is. What happens in a double replacement reaction? Well, the metal from each element switches places with the other metal. So when I rewrite this on the right side, lithium and calcium switch partners. So now I'm going to have calcium and it's mixed with phosphate, okay, plus lithium chloride. And I never have enough room for all of that, but that's how I would do it. That finishes the word equation. Now I'm going to go ahead and do my formula equation. So I go and I look at my ion, my periodic table of ions, and I know that lithium is Li plus 1, phosphate is a polyatomic, so it's PO4 with a -3 charge. A +1 and a -3 don't cancel. So I'm going to say Li3 PO4, just like that, plus calcium and chloride. So now I'm going to say Ca plus 2 and Cl minus 1. A plus 2 and a minus 1 do not cancel, so you crisscross. So you're going to have Ca, Cl2. Okay? Now I draw my arrow on both spots. Now, what's nice about this in a double replacement is what I have on the left, those ions will carry over to the right. So I already know what my ions are. I'm just mixed them up. So I have calcium and phosphate. So that's Ca plus 2 and PO4 minus 3. A plus 2 and a minus 3 do not cancel. So Ca3. Remember, when you have a polyatomic and you're writing a number outside the polyatomic, you have to put it in parentheses. Okay? Plus lithium chloride, Li plus 1 and Cl minus 1. A plus 1 and a minus 1 cancel, so I have LiCl. Okay? Now, we're not done. I know this seems like a lot for one problem. Now you have to balance. Okay, and I'm going to do the shortcut version just to save time. So I have 3 Li's here. How many Li's here? Okay. I have 1. So I put a 3 in front. Okay. PO4s, I have 1 here, but I have 2 here. Uh-oh. So I've got to put a 2 in front for my PO4, which now changed my Li to 6. So I have to go back over here and I'm going to change this to 6. So now I have 6 Cl's. How many Cl's here? 2. So I have to times that by 3 to make it 6, which gives me 3 calcium here and 3 calcium here. Now that was a hard one, but I was able to do that in my head. Now for those of you that this is not easy for, do not try to balance these in your head. Remember, write them out like we did on Tuesday. Okay, write them out so that you know how to balance these, and then put your coefficients in. You may have to use a piece of scratch paper to do that, and that's okay. All right. Okay, so let's move to the next one. So this next one, I have copper 2 metal. Now, a lot of people get confused and think this is a compound because it says copper 2 metal. Metal doesn't mean anything other than it's a metal. Okay, that's not a separate element. So copper 2 just means that it's an element. Okay, so here I have an element and I have a compound, carbonic acid. Remember, on that help sheet, I gave you guys some common acids. And if you don't know what carbonic acid is, remember, I ate something icky. So ick is ate. So carbonate is an acid. So carbonic acid is just going to be hydrogen carbonate. Okay, and that's a tricky one. Or you could have also written this as hydrogen carbonate. Now, you're going to notice on your sheet that you guys get a lot of the acids, I went in parentheses and put the other name, okay, the non-acid name. The reason I did that is so you guys know how to switch them. When you're switching them, it'll be easier for you to switch them if you look at what's in parentheses, okay? So for example, I would have written hydrogen carbonate in parentheses next to carbonic acid. That way I knew that copper 2 metal, copper's a metal, so it's going to swap places with another metal, right? Because this is a single replacement reaction. So copper is going to swap with the metal, which is hydrogen. So now when I write it over here, I'm going to have hydrogen by itself plus copper 2 carbonate. Okay? Now I'm going to write out my formulas. So I have copper. When copper is by itself, you don't put a charge on it. Copper 2 does not make it have a subscript of a 2. All that's telling you is that it has a +2 charge, and that's only important if it's bonded to something, okay? Copper's by itself. The only time, and I'm gonna move this down a little bit and show you something. The only time we write subscripts on elements when they're written by themselves is when they are in Brinkelhoff. And I don't know if you guys remember that. We talked about that, now it's 2 weeks ago, right? Because we just had a week of a snowdrift. So it's been a while since you guys have done formula reactions. So remember, anytime an element is written by itself, it will get a 2 only if it's one of these 8 elements. Okay, so you may want to write that on your paper. All right, so let's go back to this one. So now copper by itself is not one of those 8 elements, so you just write it as Cu. Now, we already wrote the formula for carbonic acid. Okay, so we have that formula written. Now I'm going to write hydrogen. Now, is hydrogen one of those 8 elements? Well, let's look. Ah, yes it is. It's in Brinkelhoff. So when I write hydrogen, I can't leave it as just H. I have to write it as H2. And then I'm going to react that with copper 2 carbonate. Copper 2 is Cu plus 2, and carbonate is CO3, parenthesis, it's a polyatomic with a -2. A +2 and a -2 cancel, so I'm going to write this as CuCO3. So now I'm going to try to balance it. I have 1 copper here and 1 copper here. I have 1 CO3 here. I've got 1 CO3 here. I've got 2 H's and 2 H's. So my equation is now balanced. Okay? All right, let's go to the next one. Look here. We have no plus sign on the left side. There's only one reaction in which you don't have any plus sign on the left side, and that's a decomposition reaction. So what does that mean? That means in a decomposition reaction, the compound splits up into 2 elements. So we literally, all we have to do on a decomposition is take potassium and put a plus sign between that and the bromine. Okay? That's it. That's all you have to do. So now potassium bromide here, K has a +1, Br has a -1, so they cancel. So I write my formula as KBr. Then I draw my yield sign, and I have K plus Br. Now, the K and the Br are written by themselves. So I'm going to slide this down and look up here. Are either one of these elements in one of my 8? Okay, K's not, but Br is. So Br has to be written with a 2. That means it has to be written as a diatomic element. So it's written with a 2. Now, when I go to balance, I have 1 K here and 1 K here. I have 1 Br here, but how many here? 2, right? So that means I've got to put a 2 in front of the KBr to balance out the bromines. But that's going to change my potassium, isn't it? So now I have to go over here and put a 2 in front of the potassium to balance it out. All right, we're almost there. Number 4 is ethane. Okay, ethane you will not find on the periodic table. That's why anytime you have a combustion reaction, I actually give you the formula for the hydrocarbon. That should be a hint that it's a combustion reaction, because I give you the formula of the hydrocarbon. It reacts with oxygen, and remember, all combustion reactions yield the same products. And you should already know what the words are, because all you have to do is look at your foldable and see that it's carbon dioxide plus water. Okay? Now the combustion one should be the easiest ones to write for your formula, because all you have to do is follow what's on the foldable. Now I give you the formula for the combustion. Whoops, that was C2H6 plus oxygen. Now remember, is oxygen one of those 8 that are in Brinkelhoff? Yes, it's right there. Okay, so when I write my oxygen here, I have to write it as O2. Then I put my yield sign, carbon dioxide, you should know what that is, and you should know what the formula for water is. Okay, so now I have to balance this. Now this one's going to be a tricky one. Remember, the combustion ones are always difficult. So I have a 2 here, so I need a 2 here, right? So I go ahead and I put a 2 in front. I have 6 hydrogens here, I need 6 here, so that's 3. So now I have 4 O's here and 3 O's here, which give me 7. Well, the only thing that would make 7 is 3.5. But remember, you cannot have a decimal. So what do you do to fix a decimal? You double the whole equation. So this 1 becomes a 2, 3.5 becomes 7, 2 becomes 4, and 3 becomes 6. So that's really all you have to do. Cross out those coefficients and write them right above it. Okay? All right, last one. Remember, when I give you the product side, that should tell you there's only one type of reaction that doesn't have a plus sign in the product side, and that is a combination or synthesis reaction. Okay? So you could write a C, actually let's do S for synthesis. That's a synthesis reaction in which you added 2 elements together to make that product. So what 2 elements did you add together to make lead-2 sulfide? Lead-2 plus sulfide. Or you could say sulfur, okay? So Pb plus S yields, now lead-2 means it's +2, and sulfide has a -2, so they're going to cancel. So it's PbS. Now, these 2 elements were written singular. So I need to go up here. Is it one of my 8? No, it's not. Either one. So I leave it as is. And this one is actually balanced, so we don't even have to balance it. All right, so like I said before, you guys are going to get a worksheet. And in order to get all of your points, you have to do like I showed you. Now, you don't actually have to show the ions here, like I have here, written up here. What I'm grading you on is, did you identify the reaction type? Did you complete the word equation? Okay, did you finish out the word equation? And I want the balanced formula equation. So you are going to be graded on each one of these 3 things individually. Okay, so if you miss one of them, I'm not going to take off for all of it. Okay, so it's 3 different parts. Identify the reaction type. That's the first part. Then finish the word equation. That's the second part. And then the third part is write the balanced formula equation. Okay, so like I said before, if you guys have questions and need help, please reach out and email. Okay, all right, have a great day.